Okay, so for problem 10, letter A, we have x squared is greater than or equal to 4x plus 12. The first thing you're going to do in solving this is you're going to subtract your 4x and your 12 to one side. You're left with x squared minus 4x minus 12 is greater than or equal to 0. And while you're solving this algebraically, you can treat that inequality as an equal sign. Then what we're going to do is we're going to factor. When we factor this, you're left with x minus 6 and x plus 2. These are going to equal x equals 6 and x equals a negative 2. Now we're going to use these values for test values on our number line. Negative 2, all the way to 6. Then we'll pick test values in between these 2 points, such as 0, 8, and negative 4. And these values we'll plug into the original equation to see where this actual equation is true. So first we'll start off by plugging the easy one in. We'll plug in 0. Again, back to the original equation. 4 times 0 plus 12. You have 12 is less than or equal to 0, which is false. So we know that this interval is now false. If we try our negative 4 value, you have negative 16 plus 12, which leaves you with negative 4 is less than or equal to 16, which is true. Then we'll do our last test value, which is 8. Plug in 8 here. Left with 32 plus 12, which is 44. Is less than or equal to 64, which is also true. So now that we know what intervals are true in this equation, we can write our answer in interval notation. It should be negative infinity approaches negative 2. And we're going to give negative 2 a bracket because of the equal bar in our equation. Union. We're also going to give our 6 value a bracket because of the equal bar in our equation, all the way to positive infinity.
For problem number 10, letter B, we have the equation 9 is greater than 3 times x squared. So to solve this equation, we would treat it as if it was just a regular equation with the equal sign. And then we would divide off the 3 from both sides, and we'll be left with 3 equals x squared. To get rid of the x squared, we would take the square root of both sides, and we'll get positive and negative. Square root of 3 equals x. To plug those values in on our number line, we put them in numerical order, so the negative square root of 3 will come first, positive square root of 3 will come next, and when you solve the square root of 3, you get approximately 1.732. So for your test values, you're going to want to get something that's less than that of the negative form, something between those two, and something that's greater than that. So we will choose value negative 2, 0, and positive 2. And when you plug those numbers back into your equation, you get 9 greater than 3 times negative 2 squared, which will come out to 3 times 4, which is 12. 12 is not less than 9, so this part of our inequality is going to be false. When you plug 0 in, you get 9 greater than 3 times 0 squared, which is also equal to 3 times 0, which is equal to 0. 0 is less than 9, so this part of our inequality is true. When you plug positive 2 into your equation, you get 9 greater than 3 times 2 squared, which is also 3 times 4, so you'll get the same answer of 12, which is false as we learned earlier. So here, our inequality is going to be negative square root of 3 to the positive square root of 3. And we use parentheses since our equation has no equal bar. So these numbers are not included.